All right, so we're talking about solutions, and we said we can make different concentrations of solutions. And so we need to talk about the units of concentration so we can talk about it from a qualitative perspective. So the first unit of concentration, and probably one that you're familiar with, is molarity. Right, you should have learned about this in Chem 101. Remember, it gets the symbol of capital M, and it's equal to however many moles of solute you have over your liters of solution. So when we say liters of solution, we mean the solvent and the solute, right? So the total volume of the solution. However, there's a big issue with molarity, and it's the units of liters right here. So when liquids are heated, they expand. And so even if you have the same kind of amount of stuff dissolved in the same amount of liquid, if you heat it, the molarity is actually going to change because the liquid expands with increasing temperature. And so we want to have different types of units, one that is temperature independent, right? Doesn't matter what temperature you're at, it's going to give you the same unit, or the same number. And that's where the next unit comes from. This is known as molality, right? So we have molarity and molality. And so this gets an italicized M, and molality is equal to your moles of solute, right? So same as molarity, over kilograms of solvent, right? So it's a mass now, so it's temperature independent. And notice that it says solvent, not solution, so it's just the solvent. And of course, the useful thing that is here is that it's temperature independent, right? Your molality stays the same no matter what temperature you're at, whereas your molarity actually changes. And then finally, we have one more unit, and that is the mole fraction. So you may have also learned about this one in Chem 101 when you're learning about gases, right? So the mole fraction, it gets the symbol capital X and then a subscript with whatever gas or whatever component you're talking about, right? So the mole fraction here, it's mole fraction of A. So you want to think about how many moles of A you have over the total moles that you have. And so there are our three new units of concentration. And so given enough information, you should be able to interconvert between all of them, right? So can interconvert. So you can go from molarity to molality, molarity to mole fraction, all that kind of stuff. So for example, 15 grams of sodium chloride dissolved to a total volume of 0.500 liters of water with, we'll say the solution density is equal to 0.997 grams per centimeter cubed. So what the question is asking is to find molarity, molality, and the mole fraction of sodium chloride. So let's take a look at each of these components. So we'll start off with molarity. Remember, molarity is your moles of solute over your liters of solution. So if we want to find moles of solute, think about what we're given. We're given 15 grams of sodium chloride. And at this point in your chemistry knowledge, you should be able to go from grams to moles very easily. So we have 15 grams of sodium chloride. And the conversion unit to go from grams to moles is the molar mass. And so if we look up the molar mass of sodium chloride, it's going to be 58.44 grams per mole. The grams is going to go ahead and cancel out, and then we're left with 0.2567 moles of sodium chloride. And so we can plug that number right into there. And then here, next up, we're given liters of solution. And so we see that the total volume is 0.5 liters, right? Not 0.5 liters of water, but total volume is 0.5. So we can just take that number and plug it directly in here. And then when you go ahead and plug those numbers in, do the math, you should end up with 0.5134 molar. So there's our molarity. Next up, we have molality. Remember, molality is moles of solute over kilograms of solvent. And so we already figured out our moles of solute, so we can just go ahead and reuse that number right there. So we don't have to really calculate anything there. And then what we have to figure out next is our kilograms of solvent. So let's take a look at some of the data we're given. We're given a volume, and then we're also given a density. Remember, density is a conversion unit that lets us go from volume to mass. So let's check out how we're going to go ahead and do that. So we're going to start off with a thing that isn't a conversion unit, and that's our 0.5 liters. We see that our unit of density is grams per centimeter cubed. So we have to get our volume to centimeters cubed, so that way it'll cancel out. So we know that in 1 liter, there's 1,000 milliliters. So the liters go ahead and cancel out. And then we also remember that 1 milliliter is exactly equal to 1 centimeter cubed. And so now these milliliters cancel out, and now we're in units of centimeter cubed. And now we can use our density. We know our density is 0.997 grams per centimeter cubed. The centimeter cubed cancels out. And then be careful, it's kilograms of solvent, not grams of solvent, but kilograms of solvent. So we know in 1 kilogram, there are 1,000 grams. And so now the grams cancel out, and we go ahead and do all of that math, and what we end up is with 0.4985 kilograms. Take this number, plug it into there. We have our moles of solute already, and so what you end up getting is 0.515 molal. That's how you say it, molal. And then finally, what we want is our mole fraction of sodium chloride. Remember, mole fraction will be your moles of sodium chloride over your total moles. So from this previous problem, we already have our moles of sodium chloride, so we can just take that back in here, plug it right into there with no issue. The other thing we have to calculate is our total moles. So think about our solution here. We only have 2 things in our solution. We have our water, so we need to know how many moles of water we have. And then we have our sodium chloride. So we need to know how many sodium chloride moles we have. So we already have this part of the equation. So we just have to figure out how many moles of water we have. So let's take a look at how we're going to do that. We already have a mass of the water from our previous problem, right? 0.4985 kilograms. So 0.4985 kilograms of water. And then we need to convert that into grams. So 1 kilogram, 1,000 grams. Kilograms are going to go ahead and cancel out. And to go from our mass, our grams, to moles is our molar mass. So we can use the molar mass of water, 18.02 grams per mole. Cancel out the grams. And then you get a total of 27.66 moles of water. We can then take this number right here, plug it in over here to get our total moles, which ends up being 27.92 moles. And then we can take our 27.92 moles, plug it back into here for total moles, and then what you end up getting is 0.2567 over 27.92 for a total of 9.19 times 10 to the negative 3. And it's a fraction. Mole fraction has no units in it, so there are no units for this problem. So you want to get pretty good at interconverting these units. And the only way you're going to get good at this is practice, practice, practice. So go ahead, take a look into your book or the homework for practice. And we're going to be using these units quite a bit in the upcoming section, so you do want to be very comfortable with them.